now it's time for the next part of our lecture on architecture design for AI systems. This time I'm gonna tell you a few words about data architecture, about data types and databases specifically. And once again, this is quite soft introduction to you, as not maybe just an IT person, but a person whose role is to translate the system architecture to the business users in order to get some agreement on the final architecture of the system. So be prepared for some quite easy content, quite soft, but as I said previously, it may be helpful for you in your future role as a consultant also. So let's dive into. We'll start with data types. Different data types we encounter in IT projects and specifically in machine learning projects. First, let's talk about structured and unstructured and semi-structured data. So that's going to be the first distinctions we are going to cover in next few slides. And the second one will help us distinguish between the event data, entity data, and external data. So being aware of those distinctions will help you design the architecture of IT or machine learning systems in the future, because each of them requires different technology stack. So let's go into some examples. We'll start with entity data. Entity data, you are obviously familiar with that from your SQL courses, databases courses, represent the current state of an object. The object may be user, product, price. As you can see, I have some sample examples here, like customer, product ID, order number. And it is a unique object, such as a customer, product, order. It may have many different attributes, which are the properties, like here for customer name, surname, address, email, phone, or product color, weight, price, etc. On the other hand, we have completely different types of data, which are event data. They represent the actions performed by the objects. Example, the customer opened a promotion email. A timestamp is the time when it happened. State will refer to other relevant data such as mobile device, tablet, or computer and browser. Special case for that are server logs. The fact is that modern systems generate far more event data than entity data. There can be thousands of events for every user using an application. So as you can see, we have entity data which represent the user state and event data which represent the user actions. Okay, and event data has event ID, event type, timestamp, and some extra metadata. Next, very important fact. Event data can be aggregated for business analysis, like key performance indicators, KPIs. So whenever you or your business user finds in their business intelligence dashboards numbers like number of daily active users, DAU, or weekly active users, or monthly active users, they are always aggregations. That may be also the session length, like spam spent by user using the application during one session, or click-through rate ratio, very important part of internet campaign measurement. Click-through ratio, which is the number of users who clicked on an ad or banner to the number of users who viewed the page. Rejection rate, conversion rate, all those numbers are computed via aggregation of the information, as you can see on top, of aggregation of event data. As you can see, we have event data here, and after the aggregation of multiple thousands, millions of events, we may find that, for example, ad-click parameter for sidebar is 215, but for the footer was 112. So just a group by. So sometimes it's good to make kind of the experiment, identify what was the source of the data for a KPI we have in our business intelligence system to track the technology stack used to generate this data basing on the event data generated by different sensors, whatever it is, okay? So when you compare those two types of data, entity data describe objects, while event data described object actions. Entity data describe present state, event data describe trends in time. And very important for you as the data engineer, machine learning engineer, entity data are updated and event data are appended to the file. So that was the first distinction. So now let's dive into data categories: structured, semi-structured, and unstructured data. So for structured data, you know it very well. They can be organized in tables. Relationships can be specified, can be queried using structured query language, and require a schema to be specified how the data is organized. So all those data we cope with in SQL databases are structured data. But where's the hack? At the moment, around 80 or 90% of the data, valuable data generated globally, is in another format, unstructured. So that's gonna be a next topic. But now, before we continue, just please have a look at this data. We have 5 rows: names, age, education, okay, maybe our employees. And now let's compare this data to that. Have a look at the picture on the right. So you may probably notice that we have exactly the same information here, but a bit different format. This is so-called semi-structured data. It may be written as a text file, yes, in the format of comma-separated values. Oh, no, apologies, in a JSON file, yeah, whatever. They are not compatible with relational databases such as Excel or SQL, but they have some level of organization, such as tags you can observe here, okay? They are not strictly relational, but once processed, you can use Python libraries for data, for example. Then can be stored later on in relational databases, not only SQL databases, or in the popular formats like comma-separated values or XML or JSON. So once again, the same information, but in a bit different form. Okay, and that brings us to the third option. Look at the text on the right-hand side. As you can see, the same information, but in completely unstructured way, presented in an unstructured format. But still, the information is there. So it would be a huge loss to remove such information from our data sets because the information is here. So this, as you can see, are completely unstructured data, mostly qualitative. There's no schema or model, no relationships, but we can extract some information from that using natural language processing library like and methods like named entity integration, or at the moment named entity recognition, or at the moment generative models can do the really brilliant job on extracting information from such unstructured sources. The examples are audio files, video files, text documents, post on discussion forums, system files, etc., sensor data, etc. We can store them in not only SQL databases or data lakes. So 3 different types of data: structured, semi-structured, and unstructured. Okay. So that brings us to databases. And we'll start with SQL, structured query language databases. One remark, when you try to translate this, L stands for language, Q stands for query, S stands for structured. The misleading term for many business users and for some IT guys is this query, because people say, okay, so this is the language which helps me to ask the database for the answer. Nope, it's just very limited. you should know that we have at least 4 different options: CRUD, create, read, update, and delete. So SQL language allows us to create a new entry or a new table or a new database, read, which is the query here, but also update the record or delete this. So this queue has a bit wider context in SQL, but still we have some databases. Let's start with structured one. So the structured databases, as we already mentioned, are organizing tables. We can specify relations between them. Yes. The reason why we store, obviously we can store all this data on order, customer, product in a single table, but it's gonna be huge. It may generate a lot of errors. It will be very difficult to query, etc. So that's why people split this information into different tables and work with tables which are interconnected using different keys. Like here we have customer ID or product ID. So this is, we need to specify obviously relations between them. A very important thing for us for the future and for you to know is that in those databases we work with so-called OLTP technologies, online transaction processing technologies, which are optimized for SQL commands for single transactions like CRUD. Examples of the SQL databases are Oracle, Microsoft SQL Server, MySQL, PostgreSQL, you know plenty of them. Typical applications are the transaction systems, financial systems, etc. Once again, key point is this technology, OLTP, which is not always the best one, which we will see in a few screens from now. We may have also not only SQL databases, and these are used for storing of unstructured data. And just to give you a brief sneak peek on what are the different types of NoSQL, not only SQL databases. Firstly, we have some document-oriented databases. They have no fixed schema. Data are stored in JSON, JavaScript object notation documents. Each document can have a different set of fields. This is very important, different set of fields. Example databases are MongoDB, CouchDB, DocumentDB. Example applications, document management system. So this is the first type of not only SQL databases, document-oriented. But you may have also a column databases where data are stored in columns, not rows. Yes, as you can see, it's a bit mind-breaking, yes, but it has some sense, specifically when you have thousands of features, because that speeds up operations based on columns. Example databases, such a database is Cassandra. Example application, advanced data analysis systems. So column databases. Next, very commonly used with sensor data are key value based databases. Each entry has a unique key, and the effect, we have much faster data writing and reading. Example databases are Redis, Amazon DynamoDB. Example applications, customer reviews. So this is also unstructured database. And finally, very important nowadays, are graph databases where data is stored in the form of graphs. What you can see here is the example graph where we have edges and nodes. Nodes are name, Andrzej, Tomasz, Anna, and edges are relations. Yes, so these databases focus on relationship between objects. Tomasz follows Andrzej, Andrzej follows Anna. Okay, they follow each other. All of them are customers. So, example application, social network analysis. Example database is Neo4j infinite graph, but at the moment it is extremely important in so-called retrieval augmented generation systems, which allows you to use large language models to answer complex queries over your own documents. Okay, so if you have your own database and you want to create a kind of the chatbot systems, do not use large language model fine-tuning, use rich augmented generation, and in case you have a lot of documents and very complex queries, you need to combine RAG with knowledge graphs. Yeah, so for that case, graph databases may be very, very, very useful for you. So these are not only SQL databases. Okay, so now let's go to something bigger, data warehouses. As I previously mentioned, SQL databases use so-called online transaction processing technologies. These technologies are optimized for transactions. So for example, customers buys the product, customer removes the product from the cart, customer changes the quantity of the other goods. These are the typical transactions. But at some moment, some case, we need to create analytical systems on top of those transaction systems. For example, you have huge databases, thousands of employees working with different business intelligence systems. And imagine now that all of those people ask a SQL query on Monday morning for very difficult, complex reports. It will probably kill any SQL database. So that's why engineers created many years ago a set of technologies named online analytical processing. They use data collected in databases and create a layer optimized for analytical applications. If you're interested in this, I strongly recommend you to read this article. As you can see, it's hyperlinked in my PowerPoints. This is a very nice introduction to the difference between database and data warehouse based on OLAP systems, OLAP, online analytical processing technologies. So for those technologies, systems are used to assist user interactive analysis of multidimensional data like grouping, drilling down, pivot tables. They integrate data from different sources, as you can see, as the input to such a system, to OLAP data warehouse. We might have OLTP system, transaction database, external data sources. We put them together, we generate so-called, in many cases we call them OLAP cubes, so they are pre-computed reports, yes, and then they are served using OLAP AP server to the final users. So that speeds up analytical tasks. Okay, so OLTP for transactions, OLAP for analytics. Cool. So that brings us to the data warehouse concept, which is a central repository of information optimized for business analytics. Where data sources include various transaction systems and other databases. Some of you may be familiar with that, or even work in the companies taking care about such systems. So the structure is like here you have different transactional systems, business intelligence system, maybe some domain-specific systems like sales, logistics. Then you have the pipeline. Then you have the OLAP data warehouse, and this is the middle layer, which is between your pipeline and data consumers. Once again, this is the very key for your system architecture. You must be aware of all the components, all the user needs. If they have strong analytical task, if they do analytical task, you need to take care about this. So once again, I'm aware that we are on the course on AI architectures, but you need to take care about, you must be aware of the place of your system in the whole enterprise. Data warehouse advantages: consolidation of data in one place, faster analysis, easier and faster data transformation, data enrichment and feature engineering processes, and improve data quality. But it also has some disadvantages and limitations that may be expensive, require ongoing maintenance, cleanup, transformation, data integration, and they are definitely too complex for ad hoc analytical needs. So do not overkill if you do not need data warehouse. just forget about it and do it easier. So when to use data warehouse? For data mining tasks, when you have multiple distributed databases, domain systems, large databases, large amount of historical data, like for marketing data analysis or user behavior analysis. So these are the typical use cases for data warehousing. And that brings us to the next very fashionable concept, which are data lakes. This is a repository that stores data in its raw format. So we might have different sources of data like social interactions, multimedia communication, customer data, and we put everything together in its raw format to be later on processed by the next elements in your data pipeline, like filtering, ETL pipelines, data processing, machine learning, data warehouses, data visualization. This is typically a single collection of all enterprise data used for reporting, visualization, advanced analytics, and machine learning. Contains structured, semi-structured, and unstructured data. Advantages: can store large amounts of data. Data can be structured, semi-structured, or unstructured. No preload processing required. Disadvantages: this is technology that is still evolving. We have problem specialists. Yes, data management can be cumbersome, and paradoxically, low cost can stimulate collection of unnecessary data. And finally, due to GDPR, we might have some problems with regulations, with data privacy. We store entire organization data in one place. How does it comply with the sensitivity of data, with GDPR, etc.? That needs to be resolved somehow. So when to use data lakes? For cybersecurity, this is a very typical use case. We collect logs from multiple devices for security and post-mortem analysis. So after the attack, we may identify the potential threats for the future. Or for customer data, when we need to collect and analyze customer behavior data from multiple sources and channels like web, mobile, traditional stores, e-commerce, loyalty systems, CRMs, etc. So once again, a lot of unstructured data in the raw format in one place. So that's all for that part. We covered topics on data infrastructure, data types, and that forms a solid basis for the next lecture on data producers and consumers. Thank you very much.